My name's Chris Martino. I work at AutoLogic, tech support. For 20 years I've been behind a wrench. Now I take calls all day. Probably spoke to some of you. We're going to learn about this little Volkswagen 2-liter here. Guys all excited and ready to do things? Awesome. All right, so basically, how can we test if all this is working properly? Some scan tools allow you to do an output test. Some do, some don't. Some scan tools let you do an output test while the vehicle is running. Most don't. So all the output tests are going to tell you is that the computer has the ability to control your solenoid. What's that do for you? It just lets you know the computer is working. How do you know if your actuator is stuck? How do you know if your actuator is not working? How do you know if the phaser is stuck or not working? This is what we're going to test. I find the best way to look at anything is through a lab scope. I like to know how a system works, how it activates, and what it looks like. And the only way I could see that is by watching a scope. What I did for this thing for test this is I got this kit from AES Wave. It's a front probe kit. If you guys don't know about this, you guys should get it. It's actually a really cool kit. You get a bunch of different front probes here, which is also good for checking pin tension. If you ever had a problem with connections or whatever, you can connect right into there without putting alligator pins on connectors and bending stuff. You can go right into there and you can hook up to everything. You want to get yourself a wiring diagram. This one, just a regular all data wire diagram is just fine. We want to know how much this engine is able to phase the engine, is able to phase the cam. So the easiest way to check this, the crank sensor is buried. So the easiest way I'm going to check this is everything that's up top. Right up top, you got a cam sensor right up here, nice and easy to get to. All right, got ignition coil right up top. And then in the front, you got your solenoid. It's all right here. Instead of burying everything, pulling out the computer and everything you need is right up top. So how do we hook up to it? Well, get hooked up to my cam sensor. If you get a diagram like this, which wire do we hook up to? You're going to want to hook into the signal wire of the cam sensor. Which one's the signal wire? Well, generally, yeah, it's generally the middle one or whatever. But the signal wire can only be the wire that is by itself. Can't be this guy because those two are shared. Can't be that guy because those two are shared. The only one it can be is that wire, so we're going to hook into that wire right there. Same thing with the ignition coil. Ignition coil, you got basically the easiest way to tell which one is your control wire on any ignition coil is look for the one that's a different color. Generally, they're all the same color, and the one that's different is the control wire. It's that guy right there. You can kind of see it right there. That's how I got hooked up into the engine. Yes, I pierced it. I put nail polish on when I'm done. Next thing we're going to do is hook up into your camshaft adjustment solenoid. All I'm doing on this is hooking up a power probe to it. That's it. It's just a solenoid. Disconnect it, hook up your power probe, power and ground. Honestly, it's just a solenoid. There's no diode in there. It doesn't matter which way you hook it up. Power and ground, it works. Okay, that's basically how I have it hooked up. And here you can see the cam sensor. You can barely see it. I got a probe in there for your cam sensor. And the solenoid over here is hooked up. And that's basically it right up top. You're hooked up in less than 5 minutes. I got my power probe right over here where I'm activating the solenoid. And I'm monitoring it right here on my lab scope. And that's basically what you're seeing. Up here, this is our cam sensor signal. Right here, this is your ignition control, so it's every firing event. And this is me pressing the button on the power probe. If you're going to do this test, don't press it for any longer than a second, because you'll either stall the engine or you could burn out that solenoid. There's a pop, pop, pop. That's all you need to do. So we're going to zoom in. Here you can see one complete adjustment event of me working the power probe. And you can also see you see your camshaft here. You can see every ignition event happening right here. And you can see it moving in relation to your camshaft. So before I activate it, and as I activate it, you can see the guy phasing and moving back. All right, so we want to be able to measure that to see how much it is. All right, so how do we do that? So what we're going to measure is you want to put cursors up. And you can see from the beginning of activation to the end of activation, because you can see it start to move back over here, we have 4 ignition events, all right? Pico has rotational rulers, which makes it really easy to use. You can do it with any scope you want. You have 4 ignition events. Every ignition event happens at 720 degrees of crankshaft rotation. So 720 times 4 is 2,880 degrees of crankshaft rotation. So just keep that in mind. You can see you got 4 ignition events, and you can see what we need to reference our measurement off of the same thing. So we're going to take one measurement from before the adjustment and one measurement at the last possible distance that you can measure, right over here. So we're going to take 2 measurements. You can line your cursors up right here. See, we're going to measure from here. You're going to take your cursors and line them up on just the same spot everywhere you measure. In this case, we're going to use the small pulse of the cam wheel right here. And you can see in between your cursors, you got 122.7 degrees of difference right here, basically is what that is. So then we're going to do that for the end of the adjustment. Mark your cursor up in the same spot and measure at your ignition event. You see you got 189.9 degrees of adjustment. Okay? So you need to do a little bit of math. So you got 189.9 degrees minus 122.7 degrees. You got 67.2 degrees of camshaft adjustment, or crankshaft adjustment. This one is good. So why do you need this? If you got a code for timing not reached or phase not reached or anything like that, you just got any kinds of questions, if you don't think your phaser is working, this is how you can check it. There's really no other way to do it unless you're physically taking the entire thing apart and measuring it and see how notchy it is. This whole measurement probably took about 10 minutes. And this way I know that this solenoid works, that the phasing works, and the timing is good. And it also verifies the factory information that you got 60 degrees of adjustment. I use a picoscope because I'm a big nerd, but not everybody has a picoscope. How many people here have lab scopes? Awesome. What do you guys have? Awesome. Veris Pro doesn't have rotational rulers, does it? Awesome. Well, I'm going to show you how to do it without rotational rulers. It's the same thing. Okay? You can do the same measurements using just your cursors. Same type of capture, same thing. You got four ignition events going on right here. First thing you're going to do is do a little bit of math. You're going to go put your cursors at the start of the ignition event and mark your 4. And you're going to see you got your time measurement here. In this case, you got 572.8 milliseconds between your cursors. Okay? So we need to know what that is in degrees because we want to know your degrees. So again, you have 4 ignition events. You got 2,880 degrees of rotation. Awesome. So you take your 2,880 divided by your milliseconds. You have 5.02 milliseconds per degree of crankshaft rotation. So now you basically have a rotational ruler written down. So what you're going to do is do the same measurement. Okay? We're going to measure before an adjustment event just like we did before. All right? You can see this one. We've got 24.36 milliseconds between your cursors. We're going to take an adjustment take a measure from after your adjustment. You can see you got 37.72 milliseconds. Okay. You got 37.72 milliseconds minus 24.3 milliseconds. You got 13.3 milliseconds. What's that mean? Take your 13.36, multiply it by your 5.02 milliseconds per degree, you get your 67 degrees of measurement using just a regular Veris Pro with no rotational rulers.